gonna try not
Some
to die.
assignments done.
Yeah.
They like requested that we not do it unless we absolutely had to.
Yeah. Miss Pat goes, I will absolutely not be doing
not
Zoom.
messy.
I hate it.
You are gonna be a seat.
Yeah.
Here I go again, dying.
Your stuff for next week's already posted on the board, so. And that's more of like it's still due when we do the section, but if you want to get ahead, that's basically your time to get ahead.
I think we should just do all the notes videos and then we won't have notes to do.
Basically, yeah. And go ahead and submit them all, and then you don't have to worry about it. All right, solve x squared plus bx plus c by factoring, or equals 0 by factoring. So I just want to do a quick review from the notes. So you have just general, like factoring, something that looks like this. And anyways, we'll go through and review. That's easier to see with examples. But the special types are a difference of squares. So when you have two things being squared, so if you've done if you did your notes like you're supposed to, all your stuff, you should already have this, but a squared minus b squared factors into a plus b times a minus b. Okay, and you can always check. There's never a reason to get factoring wrong, okay, because you just FOIL it back, and when you do that, it goes back into what you started with originally. So.
That was the code word. You can never get for or factoring wrong.
And see, no matter how many times I say that, people always get factoring wrong. It's not like they checked it and they can't figure out what they did wrong. They just don't check it. And they're just like, oh, I did it right. I'm like, no, you didn't. Sorry.
I'm laughing now, but it'll probably be.
Yeah, for real.
Sometimes I give extra credit for checking, honestly, so. Perfect square trinomial is when we have two options. It can either be a squared plus 2ab plus b squared is equal to a plus b squared. Or if instead we change the sign of the middle term to minus, so minus 2ab, then it would be a minus b squared. So always look to see if something's a special type first, and then if it is not, then proceed like normal. All right, so let's start with some examples of ones that are not special types. So just the normal x squared plus bx plus c. So number 4, we've got x squared minus 7x plus 10. So I'm looking for factors of 10 that add up or subtract, depending on the case of the middle term, to give me -7. So what are factors of 10?
2 and 5. Do you want them negative?
Yes, so 2 and 5. So I need something that when multiplied gives me a positive 10, but when added or subtracted gives me a -7. So that means that they both need to be negative. So then we have our factors x minus 2 times x plus 5. Or x minus 5, what am I doing? So if we were to check it, we have x times x, which is x squared, x times -5, which is -5x, -2 times x is -2x, -2 times -5 is positive 10, so combine like terms, x squared minus 7x plus 10, so we know that we did it right. I may not check them all when we do examples because it just takes time, but I would highly suggest that you check them. I also have the answers in front of me, so I'll know if it's right or wrong. Number 6. R squared plus 15r plus 56. So I need factors of 56 that when added together give me positive 15. What are they?
7 and 8.
8 and 7. And they're both going to be positive because everything up here is positive. So it would be r plus 8 times r plus 7. Now, when you factored before, you may have been used to writing a middle step. I only write the middle step when I do the ones that have a number in front. And again, you could FOIL to check if you were so inclined. Number 8, q squared minus 11q plus 28. So I need factors of 28 that add up to give me negative 11. Or subtract. Negative 4 and negative 7. So x minus 4, or well, not x, it's q, hello. Also, if you end up changing them all to x's, I told one of my other classes yesterday, like, if you change all the variables to x's, like, that's completely fine. The variable thing does not matter to me. Because you'll notice I end up doing that a lot. I'll be doing a problem and then I'll just completely change the variable to x, because I like x better than...
I can finally understand factoring. I hated it and I never understood it and I realized what I was doing wrong.
Usually it's very confusing when you take it the first time in Algebra 1, and then Miss Marshall was talking the other day, she's like, or not Miss Marshall, Catherine was talking, my best friend, was talking the other day about, she teaches geometry, and she was like, I did a factoring review. She's like, they didn't know how to factor. And I was like, they probably do, it probably just hasn't clicked yet. I was like, usually it's when I'm teaching it in Algebra 2 that it finally, everybody's like, light bulb, I get it. And I was like, and it doesn't come like right away, but it's usually a lot easier once, you've seen it. And also, like, my mom teaches it by a box method. I teach it by basically the arch method. And it's all the same, it just looks a little bit different in how you set it up. And then Ethan, he knows a slide method. That's what he was taught at Minchville. So honestly, it's probably easier the way that he does it, but it's confusing if you've learned it another way already.
Yeah.
So it's like,
There's just a lot of
I was like, you can do it that way, but I'm going to be doing it my normal way.
Yeah.
I tried one day and it took me so much longer to like do the problems in class because I had to like really think about it. And I was like, you know what? You got it.
You do you.
Yeah, I was like, you do you, and I'm going to do my way. He was like, okay. All right, number 10, x squared minus 4x minus 12. And also, just a quick side note, there are times where there are not factors that make the statement true. So if it can't be factored, we just would write not factorable or can't be factored or something like that. So I need factors of negative 12 that, when added up, equal negative 4.
Negative 6 and 2.
Negative 6 and positive 2. So x minus 6 times x plus 2. And again, I'm going to say it. Can FOIL to check. Try to ingrain it in your brain now. At a minimum, if you're not going to check the whole thing, I would always at least check the middle term. So minus 6x plus 2x. So it's negative 4x, because that way you at least know your signs are right, because that's probably the biggest problem is signs being wrong. 12 c squared minus 9c minus 18. So I need factors of negative 18 that add up to give me negative 9.
Negative 3 and negative 6.
So what happens if I multiply those two together?
Positive 18.
That would be positive. So that doesn't work. What are other factors of 18?
2 and 9 is the only one, but I don't think that one would just be negative 3 and positive 6.
But when I add those two together, what does that give me?
Okay.
Is this not factorable?
This one cannot be factored.
I told you something similar. I was like,
Yeah, so that's why you always have to check your signs, and that's why I pretty much always will write it this way when I'm finding my factors, because that way I can verify that I have my signs right. I can say when I multiply, is the sign giving me the right thing? When I add or subtract, is it giving me the right thing based on the signs that I have written? 14. M squared plus 8m minus 65. So I need factors of negative 65 that add up to give me 8.
I'm thinking right.
I say 13 and so I say 13 and negative 5.
13 and negative 5.
Sure.
So we know that when we add those together, that gives us 8. Multiply, that gives us a negative, so we're good there. So then it is m plus 13 times m minus 5. All right, the next ones are factoring with special patterns. So these are either going to be a difference of squares or a perfect square trinomial. So number 16, we have b squared minus 81. So I'm going to tell you another way that sometimes I allow you to earn extra credit on a test that is factoring is by telling me if something's a special type, what type it is. So, what is this one?
Difference of squares.
Difference of squares.
What were you saying?
I said perfect squares. I don't know what that means.
So I'm going to tell you, so a perfect square trinomial has 3 pieces. Difference of squares only has 2.
Okay.
The perfect square trinomial, the way I remember that it's 3 pieces is tri means 3. So think about like a tricycle has 3 wheels, so perfect square trinomial has 3 pieces.
Okay.
So the other thing is sometimes I will rewrite this so it's easier to see because it's whatever this basically the square root of each piece is what you're writing. So this is b squared, that's already written that way, minus what squared is 81? 9. So if you're used to it or if you see it right away, you don't have to write that, but I like to write it initially for everyone to see what's going on. So then we write each term and we do one with a positive, one with a negative. So it would be b plus 9 times b minus 9. And it doesn't matter which order you write them in. You could do the negative one and then the positive one, as long as you have them both. And so that allows for when I FOIL to check. Obviously, I've got my b squared. I've got plus 9b, minus 9b. So I know that I'm good. It cancels out the middle term. 18. T squared minus 16t plus 64. So if this wasn't in a section of special types, because I'll tell you on a test or a quiz, I'm not going to say solve this special type. Normally I copy instructions straight out of the textbook, but I want you to know what it is. So I will always, for factoring problems, just say factor the expression across the board. So you have to just recognize if it's a special type. Okay, if it's 2 terms, you can pretty much always guarantee it's going to be a special type because pretty much your only option is difference of squares for if there's 2 things. If there's 3, though, this kind of just looks like the normal factoring problem that we did up here, right? So, not to say that you still can't do it this way, because you can technically do any of them this way, but this is a squared term. I always look to see is my last term something squared. What squared gives you 64? 8. So this is 8 squared. So then the middle term has to be 2 times a times b. Okay. So 2 times t times 8 is 16t. So that means that the middle part is 2 times 8 times t is my middle term. Okay. So that's where you can verify that it is, in fact, a perfect square trinomial by checking that the middle term is 2 times a times b. Okay, from up here. So, and the sign in the middle is reliant on whatever the middle term sign was when you started. So, this one is a negative sign. So when I write my factor, it's going to have a minus sign in it. Okay, so it's a minus b. A minus b. So t minus 8, and it's the whole thing squared. Now, some people get a little bit confused about how to check this. They'll put the squared on both pieces and be like, but that's t squared minus 8 squared. And it's like, well, that's not true. This means t minus 8 times t minus 8. So when you go to check by foiling, this is how you would write it to FOIL it out. And then you could proceed like normal. So t times t is t squared minus 8t minus 8t plus 64 when you go to check it. But this is the way it needs to be written when it's a special type. You need to write it as 1. All right, 20c squared plus 28c plus 196. So what is 196 a perfect square of?
14.
14. So this is 14 squared. I told my Algebra 1 class, I said, you need to at least know up to 13. 13 is 169. So I was like, you know, anyways, I think y'all can know one past that. So it's 14 squared. The middle term is 2 times a, which is c, times b, which was 14. So 2 times 14 is 28 times c. So the middle term is good. Okay. So this factors into, this is a positive sign now, so it's going to be c plus 14 squared.
So are these both the perfect square trinomial?
Yeah. So this is a perfect square trinomial. Yes.
Whenever we're done with notes, can I go to the office?
Or we should be done relatively soon. We don't have that much more. All right, 22. S squared minus 26s plus 169. Oh, that's not fair. I gave you the answer. So what is my last term a square of?
13.
So this is 13 squared. My middle term is 2 times a, which is s, times c, which is 13. 2 times 13 is 26, so my middle term's good. So this is a minus sign, so it's s minus 13, and that whole thing squared. All right, now the last ones here, these say to solve the equation, so they set it equal to 0. So when we do that, what happens is once we get to our answer, I'm going to go back up to these ones. Once we get to our answer, this whole thing would be equal to 0. We set each parentheses equal to 0 and solve, and that's our solution. So we're still factoring, and then we're solving. So 24 x squared minus 8x plus 12 equals 0. So I need factors of 12 that add up to give me negative 8.
Negative 6 and negative 2.
Negative 6 and negative 2. So x minus 6 times x minus 2 equals 0. If you see equals 0, that always means you're ultimately solving for x. Okay? That tends to be a problem. People will be like, oh, I just have to factor, and then they stop. It's like that doesn't complete the problem. So for it to be all the way right, you've got to finish solving it. So now we do x minus 6 equals 0, x minus 2 equals 0. And then we just solve a one-step algebra equation. So we add the 6 over, so x equals 6. Add the 2 over, so x equals 2. So x equals 6 or x equals 2. We'll solve this equation. And you could plug either of them into the original and check it, and it would be equal to 0 on the left side. 28. B squared minus 6b plus 9 equals 0. What do you notice about this problem?
Square.
What is?
The 9.
Okay, so what special type is this?
The perfect square trinomial.
Yep, it's a perfect square trinomial. It's a perfect square trinomial, so that means it factors into what?
Numbers.
So this is 3 squared. So what are my factors? Can review back to 22 if we need to. What sign do I have?
Negative.
It's negative.
Minus 3 squared.
Yep. B minus 3 and the whole thing squared equals 0. So because it's squared, we don't have to write it twice. It's going to be the same solution both times. What you'll learn later in pre-cal is that that is the multiplicity of it. So that's how many times it occurs. So we would just say then that B minus 3 equals 0. So B equals 3 is the solution to this one. All right, now this last one's a little bit different. It's not a normal factoring problem, but it is still factoring technically. M squared equals 7m. So to solve, I need it equal to 0. So that means I need to move everything over to one side. I like my variables on the left, so I'm going to move 7m to the left. So m squared minus 7m equals 0. So now I'm looking at it, and it's not a special type. There's 2 terms, but notice it's not a difference of squares. It's minus 7m. That's not something squared, so can't be a difference of squares. So I need to take out something that both pieces have in common. So what do both pieces have in common? M. So I'm going to take out 1m. That leaves me with m minus 7. So if you distributed that back, you'd get back to what you started with. So that's how you can check that. So then we take each of these pieces and set it equal to 0. So it's a still factoring, it's just a slightly different kind. So m equals 0. Well, that one's nice, that one's already solved for us. Or m minus 7 equals 0. So m equals 7. So we have m equals 7 and m equals 0 for those ones. Any questions about factoring? All right, so because this is the first step to the factoring that we'll do in the next section where there's a number in front, I am going to give you a little bit more problems than normal, but if you don't finish today, you can have some time to do it tomorrow. I'll probably have a worksheet for tomorrow to just get some extra factoring practice. We may briefly introduce the next section on Friday so that you see it a little bit before break, and then that way, because there's no notes video for 4.4, that way when you come back, it's not like, oh my goodness, like what in the world? I've never seen this before. We factored a week ago and now I haven't seen it. So 3 through 35, every other odd, and I'm not sure if I've actually given you every other odd yet this year. So basically what that means is 3, skip 5, 7, skip 9, 11, skip 13, 15, and so on and so forth. So you basically are skipping. And if by chance you accidentally get off, and let's say you did 11 and then you did 13 and then you jump to 17, that's okay. Like, as long as you do the same amount of problems, not the end of the world.